Hello, good morning everyone. I welcome you back to my YouTube channel, and presenting before you this wonderful tutorial is your mentor, Hampio Kliman. And today I come with a very interesting topic which happens to be an introduction to complex numbers. And to those of you that are new to this channel, just make sure that you subscribe, you hit the like button, and also don't forget to share. So complex numbers are very, very simple, and if you find it a little bit tough, you want to ask a question, you make sure that you inbox on this WhatsApp line, and I'll be able to respond to you. Okay, so complex numbers, these are just numbers that go beyond the normal numbering system. So, for example, you remember that if, for example, you find a number such that it is a square root of a negative number, okay, you will discover that if you try to find the square root of that number, it will give you math error. But then in the language of mathematics, we don't want to just end at this error. We want to take a little bit further and try to diagnose what could be the way forward if a number was to be found a negative number and we want to find the square root of that number. So the knowledge of complex numbers really has helped us to simply come up with such type of numbers to comprehend what really could happen if we were to find the square root of a negative number. There must be something beyond the normal numbering system. So, a complex number is just a number that can be expressed in the form a plus bi, where a is called the real number and bi is called the imaginary number. So complex numbers are a combination of both real numbers and imaginary numbers. And by imaginary number, what we simply mean is they are numbers that you just imagine in your mind. But of course, they don't exist, but their existence is limited to our minds. We just imagine that they exist, but in the actual sense, they don't. So, these are the simple concepts that I want you to take note on complex numbers. I've written take note here to help you make sure that you get to know this. It's very important. Under complex numbers, you must know that the root of a negative number, the root of -1, is termed as I. We use the letter I to signify that this particular number is imaginary. But then we know that if we want to cancel the square root, we just introduce a root on this side, and we introduce a power 2 on this side, a power 2 on this side. Then we know that the two powers are going to cancel, and then we're going to remain with -1 equal to I. Okay? So here is supposed to be so, in other words, -1 is always equivalent to imaginary number to the power 2. Make sure you take note of this. It will be very helpful. Then, if you have I to the power 3, what is the answer? The best way to go about this one is simply to break everything down. So we know that I to the power 3 can be broken into I to the power 2 multiplied by I. But I to the power 2 is negative 1. Negative 1 multiplied by I, we get negative I. So always know that I to the power 3 is negative I. Very important to take note. If you have I to the power 4, we know that this is just the same as I to the power 2 multiplied by I to the power 2. But I to the power 2 is simply negative 1 multiplied by negative 1. And if you multiply the two, you simply get a positive number, which happens to be 1. So it's also very important to take note of that concept. So having noted this, we get back to the work. Now, we have been given this particular question. They're saying we perform the following operations and write the results in the form x, where x is a real number, and then iy, where iy is the imaginary number. Okay, so let's just do the needful. I do have some little space here, and I'm going to write just from here for the first question, maybe in the second. So this video is an overview of everything that you want to learn on complex numbers. But of course, as we go further, we take it a little bit complex. So we have 3 minus 4, of course, I plus negative 5 plus 7, I. So we treat complex numbers just like the way we treat algebra. We collect the like terms. So this is just the same as 3 minus 4, I plus, okay, this is just negative 5. Let me just put negative 5 here, sorry. This is plus 7, I. Okay, so this is just the same as 3 minus 4, I minus 5 plus 7, I. So we know that this and this real numbers. So we add all real numbers together. This will give us negative 2. Then we add all imaginary numbers together. This will give us positive 3, I. So have you seen? We have written it in the form, in this form. This is the form in which we have written it. So this is just the answer for this particular question. We get to B. What is B saying? Let's see. Okay, let's try B. B saying, B saying, this is 4 plus 2I plus 2I minus, this is negative 1 minus 3I, like that. Okay, so here the first thing we'll do, we expand everything. So this is 4 plus 2I, okay, plus 2I. Then this negative 1 multiplied by 1 is going to give us a positive 1 and a positive 3. I. Then of course we collect the like terms. 4 and 1 are real numbers. So this is going to be 4 plus 1 is going to give us 5, and 2 plus 3, these are imaginary numbers, and that will give us a 5. I. Okay, so this is just how we go about complex numbers. They're very simple. Okay, so we get on my other, let me get my other board. So that we do our calculations very, very well. Okay, cool. So let's Let's solve the other ones. So what is the other one saying? So we get to C. C is saying we have 1 plus 3i over, this is 3 plus I to the power 2. So now here, whenever you're given such a question, don't even waste time, just find the conjugate. Remember under sets what I taught? What is the conjugate of the denominator? Its conjugate is simply a 3 minus I. To conjugate is simply to change the sign here. Then over 3 minus I. Like that. From here, we are going to have something like this. So this is just the same as 3 plus I, 3 minus I. Then of course, we are going to multiply everything which is here. So we say 1 times 3, it's 3. 1 times I, it's negative I. 3 times 3, it's positive 9i. 3i multiplied by negative I, it is negative 3i to the power 2. Okay, so this is very clear and interesting. From here, this is just the same as 3 minus I plus 9i minus 3 negative 1 here over. So when it comes to the denominator, you don't even have to expand anything. You just multiply in their correspondent positions. So this and this will multiply, this and this will multiply. Just like that. You don't have to expand. So just a 3 multiplied by 3, it is 9. I multiplied by negative I, it is simply neg I to the power 2. So of course we're going to get a 3 minus I plus 9 I plus 3. Of course, even down there, it's going to be, we know that this is 9 minus negative 1, like this, because I to the power 2 is negative 1. Remember what I taught? Very important concept. From here, this is just the same as 3. Okay, this is negative. Okay, so this is just going to be plus. This is going to be 8i plus, this is going to be 3 over 10. All right, then from here, this is going to be 6 over 10 plus 8i over 10. Then, of course, this is 2 in here, this is 3, 2 in here, this is 5, 2 in here, this is 4, this is 5. So we're going to get 3 over 5 as the real, and this is going to be I4 over 5. And that is just how you solve this particular question. It is very simple and very interesting. We get to question 2. Question 2 is saying we solve for x and y given that, okay, so which one am I going to do? Okay, I'm going to do A, then you are going to solve B for me. I'm going to give you B as a work, and I want the answers on my WhatsApp line in my inbox. Okay. So we have x plus iy. Then we have 4i equal to 8. So for this question, what we do, we expand everything. So x multiplied by 4, we are going to get, okay, so x multiplied by 4, we are going to get 4 x imaginary, then plus iy multiplied by this, we're going to get 4yi to the power 2 equal to 8. From here, this is going to be 4xi plus 4y negative 1 equal to 8. From here, this is going to be 4xi, then of course, negative 4y equal to 8. So we want to get, when you reach here, remember that here we have 0i, which we can't see. So make sure that you collect whatever is real and equate, correct? And then you collect whatever is imaginary, you equate. So we have a real number here and a real number. So this is going to be negative 4y equal to 8, 4xi equal to 0i. I and I cancel, we have 4x equal to 0 over 4 over 4. And finally we get our 0 as our answer. Here we have negative 4 over negative 4. And finally we get our answer to be, this is going to be negative 2. This is just how we solve this particular question. It's very simple. Okay. Should we do B? All right. For B, we have been given 1 over, this is x plus iy plus 1 over, this is just 1 plus equal to 1. So this one is very simple. How you solve it is like this. First of all, we will deal with the denominator. So the denominator is simply x plus iy, then 1 plus 3i. This into this is 1, so of course we have 1 plus 1 equal to 1. Then of course we are going to have a 2 over x plus iy, 1 plus 3i equal to 1. So this is just the same as if you cross multiply. We have a 2 equal to x plus iy, 1 plus 3i. Of course, like this. From here, okay, so from here, what we're going to do is this, we expand everything. So this is going to be 2 is equal to x multiplied by that. We are going to get x. Then of course we say x multiplied by 3, this is going to be plus 3xi. Y multiplied by that is going to be plus yi. Then this multiplied by that, we're going to get plus 3iy to the power 2. Of course, we know that this is just the same as x plus 3xi plus, okay, so this is y I, and of course this is just gonna be negative 3. So negative 3y, because we know that this is negative 1. Then we correct the imaginaries. The reals are going to be 2 is equal to x minus 3y. This is going to be our equation 1. And the imaginaries are going to, because we know that there is a 0i here, so the imaginaries are going to be 0i equal to 3xi plus yi, like that, and we label this as our equation 2. From there, we can simply say that this can also be written as x minus 3y is equal to 2. Then, of course, this, that, and that will cancel. So it will be 3x plus y is equal to 0. Then we solve them simultaneously. We have 1, we have 3. So this is going to be x minus 3y equal to 2. Then this is going to be 9x plus 3y, like that. 9x minus 3y equal to 0. Of course, we can add. It's going to be 10x. This is 0, this is 2. So over 10, over 10. Finally, our answer is going to be 1 over 5. This is for our x. So if you try to pick any of the equations, for example, we pick this one. We pick this one, we say 3x plus y is equal to 0. Okay, so this is just the same as where there is x, we put 1 over 5 plus y equals 0. We are going to get, this is going to be 3 over 5 plus y equals 0. And finally, we'll get y is equal to negative 3 over 5. And that is just how you solve this particular question. So if you have a question over this topic, please just inbox me and I'll be able to respond to you in my own time. Thank you so much. God bless you.